All right, welcome back. This is going to be example 4 for writing quadratic equations given at least 3 points. We're going to look at a real world situation where we're studying a frog and its path that it's jumping. So in this situation here, we have a frog's path while jumping can be modeled by a quadratic function. We're going to use quadratic regression to write a model representing the vertical distance y, which is the height, vertical distance is the height, in feet traveled by the frog, where x represents the horizontal distance traveled. Okay, so vertical distance is going to represent the height that it reaches when it jumps. So what we need to do is we need to select at least 3 points. So we can choose more than three if we wanted to. So here, in most situations, our creature in this case is going to start at 0, 0. And I'm just going to keep going through until I see some intersections that are pretty obvious to me. So for me, I'm going to say 3, 1 is another point. Then over here at 6, 0. And then I also have another point at 9, 0. So I actually have 4 points that I could select from. But again, it just said choose at least 3 points. Then we're going to perform quadratic regression using this selected data. So let me write down the 4 points that I have here. We're going to have a point at 0, 0, another point at 3, 1, another point at 6, 1, and then another point at 9, 0. Okay, so now let's use quadratic regression. Let's pop up Desmos. Okay, so we're going to add our table. So we're going to have 0, 0. We're going to have 3, 1, 6, 1, 9, 0. Okay, then I'm going to go to the next row. We're going to create a function, y1. We're going to create a relationship between y1 and x1. It's related to ax1 squared plus bx1 plus c. Okay, so make sure I have all these typed. We have an odd looking a here. So it's negative 0.055555556. I'm not sure what that is. Maybe I can click on a and turn it into a fraction. All right, there we go. That's actually a little bit neater looking than this decimal that they gave me. If I wanted to know what b is, on here you don't see it on my screen, um, but a is going to be negative 1/18. So let me fix that so you can see what it looks like here. Give me just a second, maybe. There we go. So let me pull this up just a bit more. May have to cover myself up here. All right, maybe not. All right, so anyways, what you're not seeing on my screen is A is negative 1/18. So I'm going to have, um, well, I can kind of, I could actually just do it this way. I'm going to pull this up one row. There we go. So A is negative 1/18. So that's a little bit easier. And then B is 0.5, so I can convert that to a fraction as well. So that'd be a little bit easier. Okay, so the function I'm going to have is, so we don't have, I guess we'll just call this f of x here. So f of x is going to equal negative 1/18 x squared plus 1/2 x plus 0. So the actual function is just negative 1/18 x squared plus 1/2 x. We're going to identify the vertex using the equation found in part B. So in order to get the vertex, what we need to do is identify we're going to identify our b, or negative b minus, or negative b over 2 squared. So that value is negative b over 2. Okay, and I did it this way so you can see we're going to convert this into a fraction. That is your um, b value here. That doesn't make a whole lot of sense. Oh, over 2a. I totally forgot about the a part. There we go. Our b value is going to be 9 over 2, which is about 4.5 if I'm not mistaken. There we go. So 4.5, and if you look on the actual graph, there's your 4.5, and we could actually draw a dotted line here that represents the axis of symmetry. It's not the greatest line there. So we know it's going to be at negative or at 4.5. And then the value, what we want to do is plug in 4.5 to our function. So let's create a function. So this was f of x equals negative 1/18 x squared plus 1/2 x. And then we're going to call the function by passing in 4.5. And you'll see that the height of your frog there is going to reach 1.125. And that would make sense in this case here. So 1.125. Okay, now I'm going to go ahead and hide my Desmos here. So what we're looking at for the final part of this is we're going to state the domain and range of the situation. The domain, again, domain is going to be your x value. So let me do this. Domain is x. Domain makes sense to go from 0 to 9. So 0 less than equal, x less than equal 9. The range, those are going to be your y values, goes from the lowest of 0, less than or equal to, not x, but y, less than or equal to, and then the highest point of the vertex would be 1.125.